A very good morning to the viewers. We are from Group 3 and our project title is Smart Blood Transportation Monitoring System. My name is Jason Taming Kwan and I'll be introducing our project's background. So before we begin, it is important to know what exactly a Smart Blood Transportation Monitoring System is. In short, this monitoring system is a system that is able to monitor the conditions of blood packs as they are being transported from the source hospital to the destination hospital. So, why exactly do we need such a system? Well, the answer is simple. Malaysia is currently suffering from a shortage of blood in hospitals. The cause of this can be broken down into several factors. First of all, COVID-19. Due to the pandemic and MCO, Malaysia experienced a drastic 40% reduction in donated blood packs. During this time period, hospitals could not cope with the amount of blood that was needed for thousands of COVID patients that were coming in. Contrastingly, this problem worsens this year as MCO is slowly lifted. As more elective operations start resuming businesses, the number of accidents rises, which also increases the blood pack usage by hospitals. To make matters worse, the lifting of MCO just so happens to coincide with Ramadan, the Muslim fasting month. Generally, people who are fasting do not donate blood, and with all of these factors combined, the blood shortage issue in Malaysia has become even more prominent. So, as IT students, what can we do to solve this issue? Well, the solution is simple. Even if we might not be able to ensure that people donate more frequently, what we can do is to make sure that all donated blood packs arrive at their destinations in tip-top condition. That includes being within the optimal temperature range, optimal pressure range, and making sure that there are no leaks or rough handling during the transportation progress. And that brings us to the objectives of the proposed project. We aim to develop a smart blood monitoring system that is able to monitor the environments of blood during transport in real time. This means that IoT sensors and cameras would have to be installed in every ambulance that is transporting blood. These data and footages are then fed into the AWS IoT services in real time to be processed and logged. Moreover, our project also provides hospital admins with an all-in-one centralized system where they can monitor the conditions of blood packs in transport, keep track of blood transportation schedules, and also view key insights regarding past blood transportation records. Last but not least, our proposed system is able to notify hospital admins if anything ever happens to the blood packs in transport. The ultimate aim of our project is to aid hospitals in monitoring transported blood more efficiently.
I'm Dalman. I'll be presenting the part of Chapter 2 literature review in the report. In the literature review, there are 3 platforms being studied, including AWS, Alibaba Cloud, and Google Cloud. However, only the services in Google Cloud and AWS will be compared according to the project needs. The project will save the images obtained by the IoT camera, so AWS, S3, and Google Cloud Storage are compared. First, S3 is more reliable while Google Cloud Storage is more scalable. The Google Cloud Storage hot tier is obviously more costly than the AWS, which does not meet our demand to read the images and display the images frequently. Then we compare the DynamoDB and Firestore for storing IoT reading in the burst translations. The quantity of data saved is unlimited with DynamoDB since it allocates additional storage as the user save. In this case, DynamoDB is more suitable because we are not going to worry about any storage allocations. Next, to identify the blood leakage and intrusion, we require AWS recognitions or Google Cloud Vision to analyze the images. AWS recognition had a low relevance rate than the Google Visions, but it managed to discover at least one relevant label for each images. Because we were not going to miss any possibility that the blood is contaminated or stolen, the AWS is chosen. Next, the serverless computing service of AWS Lambda and Google Cloud functions. Compared to the Lambda, the function is lower when the function is heavier, so Lambda will be chosen. Lastly, the IoT core on both platforms use HTTP and MQTT protocol. However, AWS IoT core support WebSocket for asynchronous communications. So, the AWS IoT core is selected to gather the data. As a result, all other AWS services will be used for this project to ensure the overall system integrity and lower the complexity of the development.
Good day to Dr. Michael and Dr. Ashwani. I'm Tan Jingjie. Now, I will present the system architecture. As shown in the system architecture diagram, it has been separated into 6 modules. Let us look it one by one. First, in IoT devices data collection and processing module, this starts with IoT end device set up in an ambulance that are camera, GPS location, infrared thermostat, and barometer. Next, an IoT card is configured to collect the data from IoT devices. Then the data is appended with current timestamp and ambulance ID into a JSON message object. After that, the IoT Hub sends a JSON string to AWS IoT Core using MQTT protocol. While the IoT Core receives input, the Lambda is triggered. The Lambda is processing unit for every IoT reading. First, Lambda will decode the image and store the image into S3 bucket and execute image recognition. Second, if there is any abnormal event, the Lambda will trigger the SNS to notify the destination hospital contact person. After that, the Lambda will store the IoT devices reading and notification history into the data storage. Meanwhile, a CRUD function is provided for business logic. AWS serves as a backend Node.js to query and get data from the DynamoDB and forward into the client browser using API gateway and HTTPS protocol. Next, the notification and display module having two responsibilities. First, via AWS Amplify, a momentum connector has set up to handle the user authentication from the end system, which is React Web Application. Second, where a hospital contact person is signed up, this module needs to create a SNS topic programmatically, which is used to email them when there is any anomaly occur. Last but not least, the dashboard module is used to visualize data from this smart blood transportation system. The data is queried from DynamoDB using AWS Antenna. The purpose of this visualization is used to allow hospitals to predict the blood transportation trend and make appropriate decisions for the future. That's all for the system architecture, and now Chunming will proceed with the future work.
Hi, Dr. Michael and Dr. Aswani. I'm Chunming. Now, I'm going to present the future work. For the future trend for IoT devices, it is able to manage and handle the events including plotting, monitoring, checking the data. So this is able to improve the efficiency through the AWS IoT Core. Next is the AWS recognition and the SNS future trend. When none of these scenarios occur, then it will immediately alert the user through the Amazon SNS. For the future improvement, we plan to build a mobile app to let users easier to manage and monitor the data, and then we plan to use the SMS and the phone call features to immediately notify the user. And also, we plan to use the other Amazon Web Service, include Amazon Location Service to get the user real-time location, Amazon Translate to translate the content to other different languages, Amazon Comprehend Medical to convert the unstructured medical records, Amazon Managed Blockchain to improve the security, Amazon Content Ledger database that is more secure compared to the general database. In conclusion, we will utilize much more AWS service includes IoT Core, recognition, S3, DynamoDB, Lambda, API Gateway, Antenna, QuickSight, SNS, and Cognito. So we utilize the AWS service that mentioned before to create a smart blood transportation monitoring system in order to monitor and track the complex and the transportation.
Now we proceed to the system demonstration. According to the system architecture, the smart blood transportation monitoring system has developed. First, let us look at the IoT device data collection and processing module demonstration. Now, I will simulate a script from the Cloud9 environment. However, beforehand, we need to install related library via pip command. First, the Python script and related image are uploaded. Next, the Python simulation script is executed. After execute, the IoT Core will capture the data. Next, the Lambda is triggered so that we can file the entry in the database. Let us look at the React application. The history can be found. Moreover, if a for loop is executed on a script, this means that it simulates a real-time event. The React application can always view the real-time update. Lastly, since the data is exceeded the threshold, we can find that the SNS is triggered. The related hospital contact person will receive the email alert. Besides, in the React application, a history of notification will be recorded as well. That's all for the IoT device data collection and processing module. Next, I will pass to Wayman for the recognition module.
Now, presenting the part of recognition in S3 setup, that we have to create a data set. can choose training and test data so that the test data will be used to evaluate the model being trained. So we can choose upload from the computer and create the data set. After that, you can upload the images by clicking the actions here to upload images to the respective data set. I've already uploaded one. Before we can start labeling the images, we have to add a label. And we can add the label here, give it a name and add label. As I already have one, so I will not have to add it. So I can choose the images and label the images, label the object inside the images, just like this. So that click done, save changes, it will show here. If you are labeling all the images on the data set, you will see here the label images number will show equivalent to the number of images in the data set. So that you can click on the train model button to train it, you will see a result like this. This is a train model being trained, and we can run the model by starting the object. I already start it and we'll using the ARN value to specify the custom labeled model here. Set implementation here. In these functions, we'll use the images from S3 to detect it, and the SS, other than detecting the blood, we'll also detect the humans. So we'll use the usual label detection inside here by specifying the images from S3 and also maximum number of labels, and we can run it. We will print the label containing the person label and also the linkage label.
Now, I will demo the user subscribe to Simple Notification Service and also the CRUD module. For the user subscribe to the Simple Notification Service, I also create function. My user create an account, and then this email will show up in the homepage. As you can see, this is my email. Then when come to hospital page, it will prompt the user to fill in the hospital records. So I submit it. Then my record will be added in this database. After I submit my data is existed in database. From the scenario I have done just now, because the data source length is equal to 0, so it means that there is nothing in this data source, so it will render the app hospital page conditionally. So it will read the user email, which is from this user.js page. This is using React Redux library to save the user email as a global variable to let all the pages to access it. So when user fill in the details, it will submit all the just now 4 attributes with the emails to the database through the port API. So this is the Axios post method. The post method is using the Lodash post method, and then post the data to this Amazon API Gateway info URL. And this is the path. And also we need to configure the headers as well. Just now I've created the hospital record by using my email. So if now I click the hospital page, it will immediately show my particular data records. This is because my data source length is over than 0, means that there is the record. So it will immediately show the record. And the table is using the NTTD library, and this is the data column. So the Axios.get functions that import from the Lodash. You will get the data from the info URL, and then this is the particular path. Now for the delete function, as you can see, the BT050 record is existed in the database. So if I manually key in this here, I delete it, the data is be deleted, and then I refresh the DynamoDB database. And then the BT050 record is disappeared.
A very good morning once again, and I'll be proceeding with the demonstration of the dashboard module. So the dashboard module consists of 2 parts. The first is an AWS QuickSight dashboard, and the second part is actually a dot map from nDesign Charts, which is an external React design library. So the main purpose of the AWS QuickSight dashboard is to allow hospital admins to view insights and try to predict trends. So like for example, in these 2 charts, hospital admins can view the number of ambulances that are currently transporting blood now. And they can also view the total number of ambulances that they have in service with the system. So in this chart, they can actually view the blood transportation details today, which include how many blood packs that are being transported today and where exactly each of these blood packs are going to. So in these next 2 pie charts, hospital admins can view the trips made to and from hospitals this month. And on a larger scale, they can also see the number of blood transportation trips made this year, which is actually categorized by month. And down here, we have a list of the top 10 hospitals that donated the most blood packs and the top 10 hospitals that received the most blood packs. So the main purpose of all these charts is to actually allow hospital admins to view which hospitals donated the most blood packs and which hospitals has actually received the most blood packs. So this makes it easier for hospitals in Malaysia to collaborate and decide that in the near future, how many blood packs should be allocated to which hospital. So this ensures that none of the hospitals ever face a blood shortage issue.
Thank you.